In today's note, we're going to be looking at electric discharge, or the physics of lightning. So what is electric discharge? Well, electric discharge is the rapid transfer of excess charge from two objects that have a charge imbalance. And basically, you might recognize this as a shock. So electrons will always move or always transfer from the more negative object to the more positive object. Again, because they're going to be repelled from the negative one, or they're going to be attracted to the positive object. And if they rapidly transfer, that's when you get an electric discharge or a shock. The greater the charge imbalance, so the greater the imbalance between those two objects, the more noticeable the spark. So this is where we come and look at lightning. So while lightning is, or the causes of lightning are not fully understood, it can be simplified to basically a dramatic electrical discharge. So again, just referring back, it's a rapid transfer of electrons. So how does lightning work, or how do we think lightning works? So basically we have clouds and the water droplets rub together, creating a negative charge. So this charge collects at the bottom of the clouds. So we have our clouds, we have our negative charges collecting at the bottom of them. This negative charge induces a positive charge in the ground. So we talked about charging by induction. So when you have a negative charge or a charged object against a neutral object, it's going to repel those like charges. So in this case, it's going to repel the electrons in the ground, push them away to make the surface slightly positive. This creates a charge imbalance between the ground and the cloud. So the cloud is negative and the ground would be positive. The clouds would be more negative than the ground, because remember, the ground is technically neutral, but that induced charge makes it slightly positive. If this imbalance is big enough, an electrical charge or an electrical discharge will occur. So basically that's where we get the quick transfer of electrons from the one object to the other, in this case from the cloud to the ground. So again, just summarizing that, water droplets rub together, creating a negative charge. This negative charge collects at the bottom of the clouds. This negative charge induces a positive charge in the ground. And remember, charging by induction is when two objects come close to each other, but they're not touching. So the negative charge pushes the electrons in the neutral ground away, creating a slightly positive charge. This creates an electric imbalance between the clouds and the ground. And if this imbalance is large enough, an electric discharge will occur, which displays in the form of lightning or a large spark. Lightning rods are just basically, they're a way to provide or a method of providing a safe way for electrons to travel to the ground by providing a path of least resistance. So you see a lot of these on really tall buildings. You might see them on some houses. I think you see them on some airplanes, stuff like that. Basically anything that may be close, or anything that's really high, because in that case, there's a good chance that, again, if the electric discharge is trying to find a way from the clouds to the ground, it's probably going to find the easiest path, which would be the highest object or the closest object to connect to. So that's why the lightning rods are there, because we don't want all the electrons or all that electric discharge going into the building or into a plane, because who knows what damage it could cause. So that's why it goes through the lightning rod, which is connected directly to the ground. So all the electrons hit the lightning rod, travel through a wire, and go right into the ground or the earth, and the charge gets dissipated. So you still see a spark or lightning, but you don't see any of the after effects or any damage caused from that. So that's just basically a quick look at lightning and how we think it's formed.